going to the chapter fugacity of a component in a mixture by equation of state. So the fugacity is always of a component in a mixture. Why it is used? Because it is a phase equilibrium calculation. We also have learned that fugacity of a component can be determined using the concept of residual property. What is that? Residual property required equation of state, that is the EOS, and it is helpful in determining the fugacity coefficient. So as you can see, so this is phi I is the viral gas equation of state and Z is the compressibility factor. So Z equal to 1 plus Bp by RT. What is Bp by RT? B is a variable, P is the pressure, R and T. So for viral equation of state, so 1 plus Bp by RT ln F by P, F is the fugacity, integration 0 to P, compressibility factor minus 1 by P dP. So from there you can get thus ln phi, that equation, and the second virial coefficient. So ln phi equal to Bp by RT is the first virial equation, and the second virial equation you can see y1 square b11, it is like a matrices form. So the equation ln phi Bp by RT is applicable to the pure substances as well as mixture. So for mixture, the term B12, as you can see from the equation 2.23, is determined using virial mixing rule, and thus the second virial coefficient for the mixture can be determined by the equation 23. This is the first part of the fugacity of a mixture by equation of state. So from here, for gate, you need to learn the first equation, that Z equal to 1 plus Bp by RT, and 2.23 equation. So from this page you can see that we are deriving the full delta 12 equal to 2B12 minus B11 minus B22. So delta 12 is a function of temperature of virial gas mixture, and the fugacity coefficient of component 2 with respect to component 1 has been given. From this derivation you can get that, but this derivation is not important. You can remember the final form, that is 13.3. See from the example also you can see for 13.1 example. So show that for the binary gas mixture, virial equation justifies this relation. This is the derivation for the same. So summation yi ln phi I equal to ln phi. Phi I is the molar property. Phi I, ith component, the molar property. So you can see a cap above the phi I. But for the mixture, phi equal to Bp by RT. So phi I is the molar capacity of that for the ith component. Example can make it more clear. In every equation you have to keep in mind that, see, the activity coefficient, that is the phi, Z equal to 1 plus Pb by RT will satisfy that activity coefficient of any mixture of the component 1 and 2 in a binary. That's how you are getting the Gibbs energy GE. You can see from the calculation.